Today we're going to do an experiment to see if changing air pressure can cause an egg to fall into a bottle without us touching it.
Okay, you have two bottles here.
This one is going to be the control bottle, which we're not going to light the paper here, and we're just going to put it in and put the egg on top. This one is the experimental bottle, which we are going to light the fire, put it in there, and then put the egg on top.
And when you put the egg on top, what do you think will happen?
It will fall down into the bottle. And that's
because of change in air pressure?
Mm-hmm.
Okay, let's see you do this experiment.
Mm-hmm. All right. I will light the fire.
Yes.
Yeah.
Carefully light a fire.
Need the other hand.
Okay, get that fire going. Okay, that's pretty good. Now go ahead and put that in the bottle.
There we go. There we go. Look at that. It's sinking in.
Sinking in? Oh, something got sucked in there. The egg kind of broke apart.
Yeah.
And that's okay, because I think your point has been demonstrated. Oh, is it a tasty experiment?
Yes, it is a tasty
good.
experiment.
I wonder if it would taste so good if it had failed.
I don't think so.
Okay, so what did you just demonstrate?
I just demonstrated the heat. Well, there's two air pressures. If you cover the top with an egg, then what will happen is there will be the heat here and the cool one here.
Okay. Oh, I see. So there's
And
hot
then,
air in the bottle and cold air outside the bottle.
Yeah,
okay.
and then this one will pull it in. The heat will pull this in. And then the cold air will push it in, causing it to go through the mouth of the bottle.
Yes.
Into the bottle.
Well, you know, one thing I noticed was the egg wasn't sucked in when the fire was burning, which is where the heat is, but it only got sucked in after the fire went out, when things started to cool down again. So what does that mean? Does that mean that the heat, it caused the air to expand, right? It caused higher pressure. But when you put the egg on there and it started to cool down, then you got a lower air pressure and it sucked it in that way, huh?
Yes,
Is that what happened? Okay.
The lower air pressure, because here when it burnt out, the cool air would be the higher air pressure.
Oh, now
and in the
I get
bottle
it.
would be the lower air pressure.
So
and
really
so
what happened is the outside air pushed the egg in?
Yes.
Is that what happened? Okay.
And then this was helping it by pulling it in.
I see. Now what happened over here with this other bottle, this control bottle? What happened there?
Well, because we didn't light the fire, as the instructions told us, well, and because we didn't light the fire in here, it didn't get sucked down because this is just cold air in here, the same as here.
So the pressures are the same, so there's nothing gets pushed or pulled.
No, and it just stays right there.
Well, that's pretty amazing.
They keep this one pushes here, and this one pushes here, so it's all like right here.
Okay. So is this how a car engine works?
Yes, actually, it's how a piston works.
So in a piston, you make a fire in a piston, right?
Yes.
And then it pushes the push rod out, right? And then when it cools in, the rod comes back in, right?
Yes.
So these changes in air pressure is what makes a car wheel go in a circle? That sounds complicated.
Well, it is.
Okay.
Unless if you're an automotive expert.
Oh, okay, which we are not.
No.
Thanks, Xander.
No problem.